Malaysia Green Building Council, also known as Malaysia GBC, is an organization that promotes green building programs, technologies, and design practices, aims to make Malaysia an eco-friendly and sustainability place on Earth. Malaysia GBC was founded in May 2009 by a group of passionate building consultants, academia, and representatives. Even since Malaysia's building has increased, the efficiency of resources used in each building was built with green in mind. Malaysia GBC is also supported and associated with most of the top industry institutions. In the year 2015, Malaysia GBC became an established member of the World Green Building Council and known to be the only organization in Malaysia to be supported by the World GBC. Malaysia GBC continues to be the platform that networks, promotes, educates, and most importantly, develops the sustainable, built into the land of Malaysia. With much more passionate industry professionals, we can make Malaysia a greener and better place on Earth.
Good morning, ladies and gentlemen, and a very warm welcome to today's Pocket Talk. As you all know, we have a very interesting and exciting title today, and as well as a very interesting and exciting speaker. Tackling energy consumption, reaching sustainability goals at no extra cost. Cost, of course, is a big criteria for all of us when we operate systems and buildings. So here we are looking at the very core and heart of what matters to building owners as well as systems operators for their benefit. So the performance drift or leakage of HVAC systems, allowing heat infiltration or the cooler from escaping from the building envelope, is the cause of over $10 billion per year of wasted energy in the USA. In this session, we will learn how small upgrades to your HVAC system can reduce energy consumption and help your organization to reach its sustainability goals, where you use less and perform more. Our 2x22 initiative and net zero commitment in our sustainability efforts, and when I say ours, I refer to Armstrong's, leads the industry as we show how HVAC efficiency represents an enormous opportunity to reduce our environmental impact. Join us to learn how we can help building owners and operators significantly reduce their carbon footprint with fluid flow solutions for new build and retrofit projects that pay for themselves in energy savings. Now, ladies and gentlemen, I'm going to introduce our very exciting speaker today, Chris Hahn. Chris is the Regional Sales Manager for Armstrong Fluid Technology, covering the markets of Singapore, Malaysia, Indonesia, Thailand, and Vietnam. He works closely with the Southeast Asian representatives and business partners for Armstrong's design envelope and fire solutions. Chris has more than 12 years of experience in the pump industry. Prior to joining Armstrong, Chris was from the oil and gas sector, having distributed pumps from Peerless to Patterson. Ladies and gentlemen, kindly give a warm welcome to Mr. Chris Hahn. Chris, the floor is all yours. Thank you.
Well, thank you, BK, for your exciting introduction to me and for the topic. I think today's topic is very interesting for sure, and it's very applicable to today's age. Today's title again is Tackling Energy Consumption, Reaching Sustainability Goals at No Extra Cost. So we know that globally we are having a climate crisis, and with cities needing more buildings than ever, we should look at buildings being part of the solution. And at the same time, we acknowledge that buildings produce a third of the global carbon emissions, and the climate emergency demands this swift transition to cleaner buildings. So this is pretty much what I'm going to cover, and I hope to bring this few points today to you. One being that the demand for green buildings is strong and will continue to grow. Well, we see that developers in Asia Pacific are expected to accelerate their pace of construction of such eco-friendly buildings as they take measures seriously also to mitigate the impact of climate change and also meet the rising demands for green office spaces by a lot of the tenants. The next point I hope that you can bring with you away is that energy efficient, yes, is definitely a vital component of green buildings. And of course, as the focus on energy efficiency increases, we also notice that governments in the region have also taken energy efficiency into very serious consideration, proactively pursuing green building certification programs such as LEED, taken interest in net zero energy buildings, and also begun to adopt interesting digital solutions towards enhancing the energy efficiency. The next point is, of course, over the years, as we have incorporated more energy efficient technologies into our buildings, the easy opportunities for energy savings have begun to disappear. So I would say that we have captured a lot of the low-hanging fruits, but there are still opportunities within the HVAC space to look at how do we reduce the energy. And when we start to do that, it becomes a much bigger picture, a much broader picture. And the most important thing of the entire energy practice is that we are always striving towards the same goal of having greener buildings. And indeed, we can achieve HVAC energy efficiency and savings at the same time. In general, green buildings preserve precious natural resources and improve our qualities of life. However, it's also worth noting that, not all green buildings are going to, or need to be the same, because we acknowledge that different countries, different regions have variety of characteristics that are very diverse, like very distinctive climatic conditions, very unique cultures and traditions, very diverse building types and ages, or very wide-ranging economical, environmental, social priorities, all of which shape their approaches to greener buildings. However, the message has never been louder that making buildings greener, both in the construction as well as in their running or the operation, could significantly affect the impact that cities have on climate change. Well, this is a very interesting survey, summary or report that I picked up. This was actually conducted by the Dodge Data and Analytics, where it shows the global green building activity. It was projected to continue its ascent, and almost half of the total respondents say that they expect to build more than 60% of their projects as green buildings by 2021. Right, and right now, as I went into their website, is that they're continuing to update this survey. So once the survey is up, I think I encourage you to take a look at their latest survey results. But in addition to back to this 2018 study, is that more than half of the respondents believe that rating systems provide very rigorous third-party verification that ensures that buildings operate sustainably. And business benefits such as reduced operating costs, short payback periods, and asset value increases are very strong drivers for green building. But creating that healthier indoor environment, especially in today's climate that we see, is also a growing concern, as a growing major motivator. And of course, the top triggers identified globally. Well, this is a global study. Well, so the top triggers identified globally for green building activity, client demand, environmental regulation, and occupant health. Well, of course, we acknowledge again that rankings differ from country to country. Green buildings consume less energy. And here are some statistics to share. Well, the world over, evidence is growing that green buildings bring multiple benefits, where it consumes 25% less energy, 34% lower greenhouse gas emissions, 11% less water usage, of course, have an overall 19% lower maintenance cost. And moving forward, the emphasis is in creating high-performing, resilient buildings, which not only good for the environment, but also support healthier, happier, and more productive occupants within these buildings. And for building owners, third-party verification programs such as LEED certification ensures that the project meets a higher standard of sustainable design. One thing is that for building occupants, such certification offers a peace of mind in the sense that the buildings that are going to spend most of the time in will uphold their health and well-being. And additionally, green buildings are also a contribution to the global effort to build in a more responsible way, ensuring that our buildings are having a very minimal impact on the planet. So therefore, green buildings should continue and will be a high priority for organizations using a building, developing a building, designing a building, or constructing a building. So studies have shown again that HVAC on the average is responsible for about 40% of energy consumption in commercial buildings. But this percentage is rising as building owners have progressively adopted energy efficient, perhaps lightings, for example, leaving HVAC as the primary and principal area to look for energy savings. And in addition to energy intensity, HVAC plays a very dominant role in occupant comfort. We know that HVAC systems are like the lungs of buildings. Well, it is a system that ensures there is comfort maintained in any building. And really, if you think about it, we majority of our life is spent within, inside buildings, whether is it work, for school, at play, university campuses, medical care facilities, airports, and even in shopping malls. Now, buildings have a very important role to play in sustainability for sure. And studies have shown that heating and cooling costs currently comprise about 56% of a building's energy usage. And this percentage is increasing as energy efficiency measures in other areas continue to penetrate. So while electrical usage, by example, elevators and lightings are well understood, and advances in efficiency continue to make significant progress in these areas marked in blue that you see on screen, little is happening to address the heating and cooling contribution of the energy problems, areas highlighted in red. So this is where we have approaches and solutions that can help to drive significant reductions here. But a question that you may have in mind is that why isn't everyone taking such measures to upgrade their own system? Well, we can have perhaps to discuss and look upon these 5 main reasons. One being the cost of capital, where some owners do not really see the returns on investment, or simply perhaps do not have the necessary budget in place. Next, when we talk about technology risk, well, some building owners take a very cautious approach, right, by not wanting to be the first to adopt such new technologies, but rather they let others to take the lead and see how they can fine tune from there based on the experiences of those who adopt, or the first movers. Next, when we talk about system implications, well, we're talking about how system interacts with each other, and that's something that takes some time to fine tune. Next, when it comes to tenant disruptions, well, no building owners will want to have any upgrades that would disturb tenants for long periods of time. And the last one is on lack of transparency. Well, building owners who have tried, this is really, I would say, addressing building owners who have tried different technologies and solutions in the past, have got somehow burned in the process, by not actually being delivered with what was promised. I think it was a simple case of over-promising and under-delivering. So, then the next question, the follow-up question would be, how do we as a company, as an organization, deal with such barriers in the market? And I think it has to come down to this technology that we have developed over the years. There's more than 20, we have more than 20 years of experience in this variable speed technology. And we call it the design envelope technology, which pretty much integrates the latest selection controls and hydronic tools into very intelligent variable speed load transfer solutions. They are very focused on the HVAC solutions that naturally, I would say, accommodates changes in the building demands, building design, to ensure that system performance is kept at its optimal at all times. And such sensorless technology relies on really pump-specific algorithms, which can accurately know where the pump operates on its control curve. Well, I'm getting a bit technical, but I think you appreciate it when I go on to the subsequent slides. But as a background, basically what we're doing is we're using speed, the relationship between speed and power data, to really know where the pump operates on its control curve, where the sensorless pump controllers are now set up to take control based on these factors. And in terms of sustainability, our solutions are able to intelligently deliver only the capacity required by the system at any given time, so thereby reducing energy wastage, and also through integration based on our expertise built over the years in 4 key competencies of demand-based control, fluid flow, heat transfer, and variable speed. All in all, basically this technology is really to ensure that systems components are correctly sized and matched, and of course optimizes energy consumption. Well, we know and we acknowledge that a system that is designed too small cannot keep up with demand, while a system that is too large pretty much is inefficient in the usage of its energy. So designing a system that is customized for an efficiently building envelope will really ensure that the building is only using as much energy as it needs, very much in tune with today's topic. And so, this design envelope pumps or sensorless pumps are generally installed without the use of large concrete inertial bases, housekeeping pads. So eliminating a lot of embodied carbon, a lot of also eliminated the emission of carbon associated with concrete manufacture and disposal. So I think this comes to the second portion of my presentation, whereby, we talk about from a project perspective for building owners. There are 6 key opportunities to really consider what flow can do for you. And there are 6. So the first to consider is really to consider the integration of components, including centralized pumping technology. The second being parallel sensorless pump control. Next will be a paradigm shift on redundancy. Thereafter, considering feed-forward control loops, automation and optimization strategies, and lastly, connecting assets with active performance management. Here, I want to introduce you a concept, right? And something that perhaps it's a mindset shift in a lot of the attendees today. But I think at the end of this slide, you appreciate how technology advances can actually help you save energy. So on the left-hand side, what we call is the traditional approach, where you have a control valve operating across cooling coils that is connected to a differential pressure sensor, which in turn is connected to a variable speed drive located on the wall, and that will be connected then to your pump. So during operation, as the two-way valve opens and closes, the changes in the system pressure is read by the DP sensor, or the differential pressure sensor, and then the sensor converts that signal to a 4 to 20 milliamp reading. Thereafter, the variable frequency drive will take that reading and modulate the speed up and down, speeding up the pump or slowing down the pump, deriving what is happening based on the signal that is receiving from the differential pressure sensor. And this is what I believe most of us are very attuned to, very familiar with. Now let's take a look at what sensorless technology is about and what it can do on the right-hand side. So with sensorless pump control, pretty much the changes in the system is detected by the sensorless pump control as the motor M-drawn changes. So as the control valves opens and closes, it detects it as a change in motor M-drawn. The pump control then automatically adjusts the speed and ramps up or down according to the needs of the system. So always looking for that constant feedback to adjust itself to the system conditions. Again, ensuring that there is as minimal impact or rather as minimal energy is used, pretty much delivering what the building needs. So this response is not only quick, but it's also more accurate, but at the same time saving energy and reducing greenhouse gases. Now, another interesting concept when it comes to parallel pumping. So we know that in any environment where partial load, in our HVAC environment where partial loading is the norm, optimizing system performance isn't as simple as optimizing pump performance at a single duty point. So the entire profile of the pump's efficiency at varying flows and speeds must be considered. Well, in a parallel pumping environment, this makes selection and staging strategies even more complex. You will agree with me. But however, again, like I mentioned, is that technology advances has arrived pretty much. And also he has arrived at these solutions to make it much easier, whereby now parallel pump controllers with best efficiency staging capabilities are starting to pay dividends. Therefore, parallel sensorless pump control is another strategy with regards to flow control for you to consider. So, with the rise of sensorless pump control technology, parallel pumping systems can be further optimized for improved energy savings, where remote sensors, in areas where remote sensors are not possible or not even practical to place. And when we talk about parallel pump approach, it is important to consider the staging methodology for the pumps. To this slide, this slide pretty much shows two different methods. Above, we call it the best efficiency staging, where the pumps are staged on and off based on best efficiency. And below is the traditional approach of staging the pumps based on pump speed. Also, the bottom graph is showing it's very typical of how the BMS control, where the pumps are staged on around 95% of its full speed and off at 55%. And this traditional staging, pretty much I would say, based on full loading of the pump, will not optimize the system. Now, as I begin to click through the animation, I want you to really take your attention, turn your attention to the energy bar on the right-hand side, or the power consumption bar, where it's showing the energy impact of delayed staging, especially prominent in the traditional approach where the efficiency has fallen before the next pump stage on. So what this means is that with best efficiency staging approach, during operation, you are saving energy while also meeting the demands of the building. Next year is also, again, another very interesting approach that we have, where we talk about alternative product solutions. Well, to achieve lower cost and carbon footprint, here are some alternative product solutions to consider. Reducing embodied carbon, which is mostly the materials and processes to produce the products, is going down. So this is another advantage of using parallel pumping as a redundancy strategy. And because HVAC systems are usually operating in part load, we can convert standby pumps into all duty parallel pumps by selecting multiple smaller pumps to economically handle the load with appropriate system redundancy should one pump fail. So of course, the benefits when you consider that is that you have reduced capital cost, reduced energy cost and emissions, and of course reduced footprint. So this is where you convert from, or rather evolve from, a traditional duty standby horizontal pumps with variable speed drives on the wall to a sensorless vertical inline pumps in parallel, where you're talking about two pumps in parallel and two duty pumps in parallel. So when you do that, when you consider that evolution, you are also having reduction in installed power, electrical infrastructure savings, installed savings with integrated controls and sensorless technologies. The system can be right-sized for the right level of redundancy, and of course, we've reduced space requirements. And I would say the highest value is really achieved with the design on the extreme right-hand side, where this is a design that has two pump impellers within a casing with one inlet and one outlet. And again, this has multiple benefits, being reduced installed power, coming with super efficient intelligent motors, again with senseless technology, high levels of redundancy, I would say amongst all solutions, the lowest space requirements, and again, the lowest carbon footprint. The next third approach is that we talk about feed-forward control. So when it comes to having the knowledge, the moment-by-moment capability to predict how a system should be performing and optimizing it requires a demand-based, or say a feed-forward control loop, where for any given load requirements of the process, we have a control curve that will automatically set the position of the valve or the speed positions of the device, whether it's for a fan, a pump, or a compressor, to an operating point. And from that, we pretty much know how much power it should be drawing when it is at that particular operating point. So that means we have a prediction for how the system should be performing. And the power is in this next paragraph that I'm going to share with you, or rather what I'm going to say next is that, let's say, for example, from a week later, while operating at that same system load with the same settings for all the devices on the control curve, you realize that now perhaps the system is operating differently. So we know that something has changed, and when we start looking into the system and the subsystems to diagnose what has been deviated from the expected performance. So what this does, it gives you a baseline to work forward. So to look for whether how much we are deviating. So in that sense, we can actually arrest consequential changes in the system early on with a very quick decision-making process and take the necessary corrective actions. So pretty much we are helping to maintain the performance of the system and maintain the building's efficiency levels as desired. The next one is with regards to retrofit or energy upgrade program, or some say is asset upgrade program. So whichever terminology you use, pretty much I would say we should view it as a journey rather than a single step. Over here in our organization in Armstrong, we pretty much prescribe a pump first approach, where the pump replacement is carried out early in the first phase of the project, which is a relatively minor part of the overall capital expenditure. Why we do that is because it aids us in the data collection phase. So the data collected from operation will help us to inform future equipment decisions. With accurate data on the system of operation, in many instances, right sizing of the replacement equipment means selecting smaller and less expensive components, right? I know a lot of times we tend to just zoom in on changing the chiller, as that is the biggest component of energy consumption. Perhaps you change it from to look at more highly efficient chillers, but for us here, we're looking at pump first approach. And because of how the pump makes system operations transparent to the building automation system, and like the heart in our body, it adds efficiency of other equipment to the system by ensuring optimal flow to the chillers, to the towers, thereby improving on the overall operations. And more importantly, and most importantly, I would say, with proper planning, this approach of breaking the project down into smaller sub-projects will improve cash flow for the building owners. And one interesting thing to note is that when we do these projects, it can be cash flow positive, an investment from day one, where you can actually use the energy efficient savings to finance the next step in your upgrade program. The next concept we want to introduce to you is on active performance management. Seeking to add value beyond just pump efficiency, we can actually leverage on the advances of IoT, or the Internet of Things, and that is the beauty of how technology advances has helped our industry. And to establish a baseline, what IoT enables is the capability to connect a device to the internet or to the cloud. And that is actually done through APIs, sending captured data directly or through a particular gateway. what happens at the cloud is that the cloud will then pick up and collect the data. It will manage and structure the data. And then on top of that, it provides a layer to process and visualize the data, because you agree with me is that simple raw data doesn't add any value. So it gives you very pump specific insights. So the information that goes back to owners contain very actionable insights to really let owners and operators know what is going on in the system and how each individual components are performing, and even to the extent of how much energy it is consuming. So, and again, it's also capable to also trigger automation activities. So data can also initiate other activities that react on the data being collected that's pushed from the device to the cloud. And again, with cloud-based performance tracking services, it helps in managing the pump performance and delivers real-time insights to help building owners operate and maintain HVAC systems. And having access to such predictive maintenance analytics will also allow building operators to make informed capital or operational decisions that drive better returns on investment. The last one, I think it's really about when you connect the pumps, it really allows the possibility to actively manage all the assets, actively manage the performance of your devices in the field. This visualization pretty much illustrates how connectivity completes the entire operation cycle, whether we are talking about having connected equipment, giving you that ability to track the performance, or connecting customers, whether you are on site in premises or whether you are viewing it remotely via the tablet, or connecting your users by sending out reports and alerts to them directly on their phone, or having connected service dealers, service support that triggers the alerts and alarms should any failure be encountered on your equipment. So the connectivity, I think you would agree with me, is that the key driver to keep all these intelligent buildings performing at its peak efficiencies over the long term. And continuous commissioning is still at a very specific moment in time, but it's only through connectivity can owners and operators and service dealer support optimize the equipment and facilities, resulting in an installation that is far more energy efficient. So again, we have seen successes all over the world in our installations. In many case studies where our products have been proved themselves time and time again, whether it's in Canada, the United States, the United Kingdom, China, India, I would say pretty much really the world over. If you were to zoom in on the project in the middle, the Waylai Mansion project, that is a site that I know personally. All these savings, you might think that it's just for marketing, but really it's verified. In this project, it is a site that underwent successful energy upgrade or retrofit program. It is a project where we engaged an external third party appointed by our organization to really provide the process assessment and confirmation of the pump performance with regards to energy savings. This process taken by this third-party verification organization undertook, they undertook initial baseline energy audits to establish the energy consumption both on the electrical and the water side. And after retrofitting, they will come in again to do a second audit. So all these savings that we publish here are all audited. So I think in terms of summary-wise, I think you appreciate that some of the key points that's flashed on your screen. After picking all the low-hanging fruits that we have done, what else can we do? That is the 6 opportunities that you can consider, some of which are some strategies that you can consider for your next building or even for your existing building. We talk about a technology, senseless technology or design envelope technology, where pretty much it helps you to address some of the main barriers when it comes to asset progression planning. Right, and of course, reducing a lot of energy consumption and energy carbon emissions. And our upgrade program roadmap is pretty much a low-risk, data-driven approach for such program to take place to help you to stay cash flow positive. And with that, I thank you for your time. And now I think I'll hand over the time to BK to bring us through the Q&A. Thank you.
Thank you very much for that, Chris. Extremely exciting and full of very, very interesting facts, figures for a very exciting, innovative, and creative system that you have presented. In any buildings, they are imperative, they are active, unlike a firefighting system, and they need to respond appropriately to the people inside according to the weather outside. So they need a certain amount of intelligence, I suppose. So I have a couple of questions, and if anyone in the audience has got any questions, please feel free to post them on the chat box, and we'll be happy to address them. This is your opportunity. Remember, this session is about saving money, so it's very important for all of us. Talking about that, Chris, let me first start off on a couple of questions.
Sure.
The first question I'd like to ask you is, when you say that air conditioning systems consume approximately 40% of the energy bill in a building, and I know that there are different types of buildings, but my first question is, it depends on what type of chiller that building is using. And as you know, nowadays, chillers are getting better and better at COP. So when you mention that word 40%, is the chiller 10 years old or 5 years old, or do you take an average across all ages of chillers in operation? Just to understand how that 40% is reflected.
Well, those are global studies. I think when it comes to, yes, I agree with you also, is that chillers do consume a large proportion of the energy that's coming out from the HVAC plant room. And in terms of ages, yeah, it could be the technology of the chiller itself. It could be also the age, but of course, age-wise, there's unfortunately, I do not have a study on hand to give the hard figures. But I think when it comes to chiller types, there's also one strategy to look for when it comes to optimizing and automating your control strategies to really reduce energy consumption. And sometimes when I meet customers, one of the very broad questions that they have is that, Chris, should I consider air cool or water cool chiller? Which is better? I think it's a very broad question, because when you consider those two are really very distinct, very distinct differences between these two technologies, right? Cost-wise, I think definitely we cannot avoid. You need to consider areas like cost of purchase, installation, and maintenance. I think one very, very, very important thing to note when it comes to chillers is the maintenance portion, right? So between the two, I think, between the two, just to answer the question that I have from my customer before, is that between the two, so by design and operation, I would say the air-cooled chillers appear costlier at face value, because to begin with, the air-cooled system will feature installation costs for the air ducts. You need to consider air ducts, you need to consider fans, you need to consider thermal regulation cost controls. So, and additionally, these chiller systems consume a lot of energy to power the fans for the air ducts and to facilitate the cooling system effect, right? Which pretty much translate to higher electrical bills. But on the other hand, even though the water-cooled chillers are cost less to set up, they are generally having more long-term operational costs, as most of these chiller types will need to have cooling towers installed. So also after factoring in the chiller maintenance, like I mentioned, maintenance is always a component you need to take into consideration, because you need to consider things like water quality testing, right? Where the mandatory treatment of water and refrigeration system costs quite a lot. So when it comes to water-cooled chiller operation costs, it can be quite significant. So to answer your question, I think there's a lot of considerations, and unfortunately, I don't have data that establishes at what age, when it comes to the 40% of data that's published in the presentation that I showed earlier.
No worries. Dr. Selvi, would you like to continue? I'm sorry I dropped off, but I seem to be reconnected again. I'm not sure if all of you can hear me okay. So Chris, my next question then, hopefully don't drop off again when you answer. Since we are talking about saving money, Chris, have you got a case study of a typical building which is made, for example, 20 floors high and 10,000 square feet a floor, and then before and after your systems being installed, in terms of actually dollar and cents, could you give the audience a guess or an impression or just an idea of what kind of cash they're going to save in terms of ringgit Malaysia?
Wow, you're testing my mathematics skills early in the morning. Well, because most of the dollars and cents we consider as in US dollars. So I think now the exchange rate is 1:1 to 1.4. I'm not too sure. So I will skip the.
It's actually 1:4.3. So
okay.
I'm trying to So I'm sorry, I'm not trying to put you in a spot. I'm trying to tell the audience that this is how much money you can actually save. Okay, let me ask you the question in another way. Okay, maybe this is a bit more straightforward and relevant to what we are speaking.
Yeah.
If I were to install your system in any building, how long will I take to pay back for that system, that expenditure that I'm incurring?
Yeah, actually, I wanted to share with you the case study that I mentioned in my presentation on the Waylai Mansion, which also helps to answer your earlier question and this follow-up question, I think, which is pretty much related. So in terms of payback period, I think just to give you some background on what this Waylai Mansion is. So Waylai Mansion is an office and hotel mixed-use development. It was constructed in 1997. So and the thing is that because its hotel portion is operating 24 hours daily, so it's really a good case study for us to really showcase. So for that, when we went in to really look at their energy upgrade program, the plant room, they actually have installed the traditional horizontal pumps. And when we went in to really put on our, we have a data logger kit that we put in the plant room to really start to collect data, and which formed the baseline. From there on, we worked in our proposal on how best to really help them to optimize their chill water pumps, their condenser water pumps, and even their hot water pumps. So as all these pumps have already been used for more than 10 over years, they're all constant speed. One of the significant approaches that we had was to really upgrade them to our design envelope technology. And of course, we do have other automation and optimization strategies that we actually propose to them. And of course, like I mentioned, we actually do have it audited by our third-party verification progress organization called BV Veritas, or Bureau Veritas. They came in to really assess all the process from during the whole process of the retrofit, which includes pre-measurements and of course post installation. So we did some calculation. The payback analysis for all the pumps was within, when we talk about in terms of years, it was within a period of 2 years, right? With 2 pumps in operation, or rather the pumps in operation 24 hours a day. So that is a kind of payback period that we have in mind. But I think it can definitely be below that. I think we eventually, over the years, we have also managed to reduce it to even 1.4 years after we continued to visit them to put in our automation and optimization controls. And that really, I think, reduced it to around 1.5 years. And that had an overall 75% energy savings. I hope that answered the question.
That's really awesome, actually, Chris. Of course, it does. So 75% saving and 1.5 years payback, and the lifespan of your equipment is?
Well, definitely with the equipment can last for as long as it can. I think we have pumps that are operating 25 years with no problems. It's still as silent as it was first installed. So I think definitely the lifespan, just like our bodies, the more you maintain it well, the longer it can last.
So this is the takeaway for the audience, ladies and gentlemen. 75% savings for 23 and a half years out of 25, because 1.5 years is payback. That's really awesome. It shouldn't take anyone a single second of doubt to make that decision with that kind of payback. But I have another question which could impact the performance of a HVAC system. And I'm not sure how this impacts or corresponds to or relates to your system before and after your system is installed. That is, I saw your case studies and I was wondering that we in Malaysia live along a band 5 degrees north and 5 degrees south of the equator, which is the hot and humid zone. Mm-hmm. And as you know, humidity has got very big impact on HVAC systems. Yep. Sensible heat versus latent heat, where the latent heat is the one to extract humidity, and a whole lot of energy is spent there. So my question to you is, do you think that, or do you know through your case studies experience of actual installations which you've done in hot and humid zones, does humidity impact your system? And if so, how does it impact? Is it a positive impact or any other inputs you'd like to give us?
I think when it comes to installation, I think in a very tropical climate like ours, well, high humidity is definitely something that is encountered. But when it comes to having an impact to our bottom line, I think we need to take it from a holistic point of view. Especially when it comes to the design team, because you need to also, there's so many things that are taking place, and interactions of various factors can influence that. So when you talk about maybe the from the air side point of view, if an air side point of view, as air side system that is designed for low flow can also reduce that kind of low flow rates, can reduce that energy usage to transport air and water throughout the building. A low flow design can also reduce a lot of the material costs by using smaller air handlers, ductworks, pipings, and pumps. As well as when we talk about the water side, well, we can also consider upgrading your chillers to have the VFD, the variable speed chillers, right? We know that chillers are operating for long hours, or rather consider installing a variable speed drive on chillers. Well, if the chillers are operating for long hours of the year at very low load conditions, and the cooling tower water temperature during those hours can be reduced. So you really need to compare the economics of having a VFD added to the chiller, also having the alternative of using the same amount of money to purchase a high efficient chillers. So when it comes to such practices, you can also take a look at all these approaches. When it comes to, of course, cooling towers, you also need to have, you can have cooling tower optimization strategies or controls to reduce the sum of the chiller and water energy consumption. So all these are all some of the cost saving strategies that you can take into consideration. With regards to specific case studies, I think a lot of the case studies that we have can be also, I would encourage the attendees to go to our website to take a look at some of the case studies that we have demonstrated over the years. Whether is it the United States or in a very tropical climate like ours, you can actually derive some of those numbers there, whether how humidity can also affect our whole payback period. Thank you.
Moving on, I think there's one question here that we'll be interested in. How does the design and the technology resolve the lack of transparency in energy upgrade of project?
Yeah, great point. I think thank you for the question. I think good that you pick up or learn something from the presentation. I think this was not really covered significantly in our presentation, but it was the capability of our pumps to be as effective as a flow meter because of its accuracy and because of the accuracy of the flow reading. This is why we prescribe a pump first approach when it comes to our energy upgrade program, because of how connectivity allows our pumps to collect all these flow data and other useful information such as energy consumption. And the good thing is that if you actually also observe is that all of these information can be directly read off from the display screens of our pump. These are all touch screen based, just like our smartphones. So these can also collect data over a period of time that can also be read through downloadable reports that is useful to be presented or to the owners or to the operators. So from these reports, you can actually gather a lot of information, a lot of insights into how your system is performing, how your pump is performing, and how much energy is consuming. So like I mentioned in my presentation, you can actually treat these data as the baseline from which you can provide a very clear picture of whether you're consuming more or saving energy compared to that baseline data. Thank you.
Interesting. There's one more adding on to that question. Provide those informations or those data for research purposes, be it for academia or other stakeholders. Would you all share the information on the data or information of data that you have at the moment? Can be accessed or shareable with others?
Sorry, Dr. Selva, can you repeat yourself?
My question is, adding on to your earlier your answer,
sure.
Whether the data that you've collected so far, is it shareable with other stakeholders, like for example, academias, or can we access it?
Okay, those data that are downloaded from the cloud, right? They're all accessible to the particular stakeholder. So let's say, for example, if you have a unit that is installed in TRX, so only the building owners of the TRX have access to it. And of course, whether they want to share it to the other stakeholders within their organization is up to their discretion. But pretty much this is only to their for their own reference and not to be shared outside, because but of course they can use it as a case study, taking out the name of the development, of course.
As a case study, actually, I mean, we always want data from our industry. One more question, perhaps maybe you can talk a bit more on the benefits of having just less moving parts and which might provide and if you have any evidences showing that beyond the savings of both systems are working currently.
Is it, I mean, just to repeat the question, you're asking what are the benefits of having integrated drives with the pumps?
Yeah, you've answered that. I think, right.
Yeah. So yes, why we advocate? Why do we advocate the integration of parts? But we can actually do more with much less, right? So we advocate this integration of our drives to our pumps, and not only that, right? We integrate a lot of things like flow energy meters, flow meters, even wirings into one integrated unit, and that actually reduces a lot of moving parts, as what the question says. So lesser equipment going into the building not only aids in saving energy, but I would think you'll agree with me is that the energy or rather the carbon emission related to these as well as the embodied carbon are also reduced. And then when we took at the flip side, if we look at installations with sensors, that comes with wirings and controls, they are all coming from that different manufacturers, and the installing contractors are, once they all come to site, the installing contractor will have to try to integrate all of that pieces together and try to make them all work together, versus coming from when you think about it, versus coming from a single integrated source with single unit responsibility. Definitely there is some benefit of convenience there. And one thing about sensors, sometimes when I do site walks with my customers, is that some of these sensors fail, right? So when you have sensors out in the field, there's always chances for it to fail, not giving the right signal to the VFD, therefore really affecting the tenant comfort eventually. So I think when it comes to integrated solutions, you save a lot on time, you save a lot, reduce a lot of time spent when it comes to commissioning, installing, and of course finding the right location to place these sensors. Sometimes in some locations, finding the right location to put sensors is a challenge in itself. And when it comes to typical sensors in buildings, they do provide I would say, I think in the range of 10 plus minus 10% accuracy. However, our sensorless technology can provide a plus minus 5% accuracy. So much more accurate. So basically, we are giving you information that is more accurate compared to a similar installation that comes with sensors. So I think that is how I would answer that. And really, that's the benefit of having integrated solutions.
Okay, one more question. I just now you mentioned about it reduces embodied carbon.
Yes, correct.
Embodied energy. So would you mind elaborating maybe briefly? I know we are coming close to the end, but elaborating a little bit more on how it reduces the embodied carbon.
Well, I think embodied carbon, I think is an initiative that we need to push forward with, and I think a lot of manufacturers are also trying to push towards this reduction of embodied carbon or embodied equipment within the materials, because you do agree with me is that materials within our buildings do have a large energy or rather carbon impact. Materials like steel, concrete, glass have very big carbon footprint. So any opportunity to save all these or rather reduce these embodied carbon or save embodied energy in the materials that we put into buildings will be of great help. So I would say lesser equipment going into the building not only aids in saving energy and the carbon emissions related to that, but also the embodied carbon within it itself. And I think this is also some of the, I think BK was mentioning in the earlier introduction, is that you're going forward towards zero energy building. So that is something that you can consider also, is that your structure pretty much putting back into the system at least as much energy that is taking it out. So basically you're producing no carbon emissions from all energy uses in the building. So this is something that you need to consider as one aspect.
Forward to embodied energy.
Correct.
Well, I think I've always been very concerned about embodied energy, because
correct.
Most systems that we bring into the building normally talks about the operational energy, the operational carbon. Embodied energy should be our way forward in sustainability.
Yes, agree.
It's very interesting and very enlightening. A lot learned from you today. With your presentation today, a lot of information where a lot of us get benefit. On behalf of MGBC IDM, I would like to take this opportunity. Thank you. Really appreciate it. Very interesting, very energetic. I think I've put it very energetic presentation, as well as the way you answered. Shows so much. So much energy and passion. It's really very interesting. Throughout the session. Thank you so much for making time for us today. Very interesting. Thank you so much.
Thank you for kind words, and thank you for attending the webinar.